What's going on, everyone? Believe today's day 18. Uh, yeah, today's day 18. What we did last time was just finish up a little bit of. Let me go to it real quick. Yeah, so we finished the introduction for data structures. Now we're on stacks, but I got a few comments. Well, a comment from one of my boys, my boy Loco. Yeah, one of my boys, Loco. After you learn to start streaming, so you ain't slick. So I'm thinking about doing. Okay, so people are saying doing a leak code after I learn a topic. So I think I'm gonna wait for stacks. What I'm gonna do is so some sorting algorithms that we learned already was bubble sort, merge sort. I'm thinking I asked chat. Okay, so what are some simple leak code problems that need bubble sort? Holy sh! You see that outside? Hold up. Damn, my fault. Hold up. Alright, my bad, guys. Sort colors. Sort colors, leak code 75. Weird. So, given an array nums with n objects colored red or white or blue, sort them in place. Oh. And this one need bubble sort? This is a medium. Holy shit. Colored red, white, or blue. By the way, guys, I don't have much time, so this is probably gonna be like a 20 to 30 minute video. I got to pick up my little brother, so I'm gonna solve this legal problem and then grind after I finish this video. So yeah. Let's do this. Given an array nums with n, colored red, white, or blue, sort them in place so that the objects of the same color are adjacent with the colors in the ordered red, white, or blue. We'll use integers 0, 1, 2 to represent colors red, white, and blue respectively. You must solve this problem without using library sort function. So inputs 2, 0, 2, 1, 1, 0. So 0, 0, 1, 1, 2, 2, 2, 0, 1, 0, 1, 2. Okay. Let's look at bubble sort again. This problem is representing colors while Dutch nation flag algorithm is more efficient. Bubble sort can be used as a straightforward. Okay, so bubble sort is when you check 0 to 1, 1 to. Okay, so just to be clear, bubble sort is
actually uses in the real world because it's so. The other sorting algorithms are just that much more impressive. It all starts with an unsorted list of numbers. Then
so you check the first
right
one.
and compare each pair of neighboring numbers. If the number on the right is smaller than the number on the left, we just swap them. Otherwise, we just leave them be.
Got it. Okay. So what we're gonna do is we're gonna do so wait, yeah, so that what is
When we get to the end, we just go back to the start and do it again. We repeat this process over and over and over until we go all the way from left to right without making any swaps.
Okay. So bubble source. My mom takes me. Okay, so what we gotta do is we gotta check the one before. So we'll do. So we gotta go through the first one. So we gotta do. For num in range. So we gotta start from the first one to the last one, right? I just want to test some stuff. It was 0 to 5, so 1, 2, 3, 4, 6. So 6, yeah, that's what I meant, 6. So yes, we're getting the index. So this is getting us the index. We're checking the first index with the second index. So we're doing if how would we check the next one? We need this one to be the next one. So if we do 1, this will only print 5 instead of 4. Oh shit, I did not mean to do that. Print 5, sorry, print num. So if I do that, it'll be 0 to 4, just to be sure. Like this problem would be 0 to 4. Oh, sorry, 1 to 5. Okay, so that means we start with 1, yeah. So if we print num, sorry, let's say nums like that. This should print 02110. 02110. Right, now we're getting the second one. So we're gonna compare. So we're gonna compare if nums num minus 1 is greater than nums num. We're gonna say let's just print let's just swap them. So we're gonna do nums num minus 1 nums num is gonna be equal to nums num, and then nums num minus 1. We swap them. Right? What about if I return nums? There's an issue where I think what's happening is, so 4 number, so what's the second one? Is the second one greater than the next one? I think it's having an issue with the with the double numbers. With the double numbers. So bubble sort is when you check the number next to the next number. So I think we gotta understand what my code is doing. So the for num in range, so this is getting the index of the number from index 1 to the rest. So say the num is 0. So say num is 0. If num minus 1, so if this one is greater than num's num, we're going to swap them. So we're swapping 2 with 0. That's what happened. 0 to 2. Now, we keep going back. For num in range 2. So if num's from -1, if num's -1, which is 0, no, it's 2. 2 minus 1 will be 1, so it'll be 2. And num's num. Fudge, man. Wait, I'm getting like a little lost. If num's num minus 1, which is... I need to write this out. I need to write this out. Say nums is equal to whatever that is and this. So I need you to be right here. So let's see what's happening. So if I do for num in range 1, this is getting the 2. And then if the num is range, so let's just say this nums, so wait, hold up, step 1 is num is equal to 2, and then nums num minus 1, right? That's equal to the 0. That's equal to the 0. For num in range 1 to the line num, so if nums is greater than, so nums which it is, it's greater than, we're swapping it. So now nums is equal to gonna be 0 to 2 1 1 0. So step 2 is now nums num is now gonna be 2. No, dick, this is 0. This is 2. Because if nums is minus 1, which is the left side, yep, is greater than that, we switch it. Then, yeah, that's why I got switched. Damn, I got that confused. Okay, now, see, that's why I gotta write this stuff down. Nums num is equal to 2. Yeah, now we go. No, it's not 0. It's 2 again. So now we were just at 1, index 1. Now we're at index 2, which is 2, which they stayed the same. Now this one's, the next one would be, this would be 2 2 1 2. I think I get it. 0 2 1, and that's why it's 2. Ah. So I think we need 2 for loops then. Let's call this right then. Let's say right and range there. For left and actually for this should be right and range 1 to len nums. It should be 0. Left for right, and that would be 1. So if no, so it's gonna iterate through 0 is gonna go through 1 down, boom. Then it gives you 2 2, so it brings everything to okay. If so, you know you need this. If left, hold up, guys. So for the left, the left. So the left, yeah, we gotta do if nums left is greater than nums right. We're gonna switch the left with the right. So nums right with the left. I'm pretty sure that's gonna work. Oh. And yeah, I did not indent this. Hopefully the indentation works, I'm not sure. For num iteration nums. So the second one works. It's just this one. That's what the double is messing me up. I'm gonna need to use GPT. How did I solve that here? End is len, which I don't even need. I could just put this right there. I don't get what the issue is. Do not give me the answer or any code, but I just would like some clues and hints on what I'm doing wrong. You're on track 29. That's close to bubble sort. But here's what your current source is doing. 1 pass equals 1 swap. You're only making 1 pass through the list. Ask yourself, can a single pass? No. That's why I did 2 for loops. Adjacent swap isn't enough. But that doesn't keep swapping until sorted values like 2 can remain in early positions. Try walking through it. Manually trace what your code does for 2. What happens after one loop finishes? Are all values where they belong? Compare the bubble sort to counting sort. Think about how many times you need to loop in bubble sort to guarantee a fully sorted right hand. Yeah, it's not just once, obviously. Follow him. The optimal solution uses 2 or 3 pointers or something. This is confusing. Yeah, it's just going through once. So if num for num in range that goes into here, it's checking 2. No, I have 2. Yeah, it's not gonna finish. So now we need to do it again. Bro, what is happening? There's one index as a time to the next index to check if the number is greater or not. I am a bit stuck. Can you help a little? But don't fully give. You know, I check all sorts like just one. You have to repeat this comparison multiple times, not just once. Here's a small structure clue set. Outer loop needed. Bubble sort needs an outer loop that repeats inner pairwise comparisons. Why? Because each pass only guarantees the largest. Biggest number to the end. Bulk. That's not what I meant to do. I'm stuck, man. I don't know. So add another. So what does 4? I don't know. I don't know. It's like what? It's checking it once. I know, but I need to check it again. Well, swapping equals true. Okay, swapping equals true. swapping equals true. Where is that? While swapping is equal to true. Well, swapping is equal to true. Holy fucking balls. Swapping equals true. Well, swapping equals true. Then swapping is equal to swap if then it goes backwards. So then we need a swapping is equal to false. False. I guess if n is line nums, this goes backwards is what I'm guessing. I would not do this, but I'm in a rush, so I have to like kinda. So n minus equals 1. So that's twice. So swapping is true. So swapping is true. Then swapping is true. Oh, if it's not true, it's false. That's why. Holy shit. Swapping is equal to true. Swapping is equal to true. It's doing the same shit. It's doing the same shit. Why? Damn, I gotta go. Holy shit. Inside the while loop, it's not even inside of it. Oh, yep, it is. Basically the same shit that the other one did. I would like for you to explain to me every single line and what it is doing so I understand. Hold on guys, I'm gonna start my car and then I'll come back. Give me like 2 minutes. Well, 1 minute. Maybe 30 seconds. Let me just start my car and come back to understand. If I know where my keys are. If I know where my keys are. What the hell? Where's my keys? Okay. I'm gonna do this, come back, understand? Alright guys, sorry. I wish I could cut that out, but it's just I don't really edit. So okay, so swapping goes true. This starts the algorithm by assuming the swap might be needed. You use this as a flag to decide if you need to keep looping. Okay, n equals lambda. This sets the initial range of sorting. On every full pass through the array, the largest sorted number bubbles to the n, so the next pass doesn't need to go that far. N will shrink after each pass to avoid comparing already sorted elements to the end. So while swapping equals true, so this loop continues as long as the swap in the previous pass. If no swaps in the pass, this means the list is sorted and it can loop to the end. Swapping equals false. So this resets the flag for each new pass. If no condition is true in the round, it says false to and the loop ends. For number range, so this goes from the second. This loops the index from 1 up to the end minus 1. Why from 1? Because you're going to compare nums 1. Right, if nums, I get all this, but the swapping is true. If the current path, the current pair of out of the order and you swap them, you set the flag to true, meaning you'll go through the list again. So nums minus 1, the swaps them, and minus 1 is you go 1 down. So just in case, okay, the biggest number has bubble to the correct place at the end, right? So there's no need to do it again. So that's why you do n minus 1, then you return it. So can we go 1 by 1 in the loop and show me how the algorithm works? Swapping is true and 6. So we'll check index 0 to 4. 0 to 1 2 0 1 2 3 4. Index 0 to 1 2. Swap, yes. Swaps happen, swapping is true. Decrease n to 5. So 2 here. So that should be 2 then. That we decreased. Yeah, this should be 2. I see how it works. I'm not that very efficient with what the hell to do, but I understand. That was a tricky one. So on my own, I guess I'm gonna do merge sort. I'm gonna do a merge sort problem, and then insertion, and then quick sort, and then tomorrow for the video I will start stacks, finish stacks, and then at the end we'll do a LeetCode problem and we'll see how that goes. I'm not really familiar with stacks. I've probably learned it before but forgot, so we'll see what happens. I appreciate you for watching this video. I'm sorry for it's short and I'm talking fast because I gotta go, but tomorrow's video we'll finish stacks and then do a LeetCode problem. So I appreciate you guys for watching. It means a lot to me. So alright guys, see you later.